Complete the equation for the piecewise function graphed below. So this is kind of different for a lot of students. You're used to seeing just one equation for a function or just one line graphed for a function. But this situation has our function split up into pieces, and those pieces have to do with what the x values are in that region of the graph. So for that first answer box, because it says to the right of it where x, if x is less than or equal to 1, I want to go onto my x-axis and locate -1 and then go less than or equal to it. So this just shows me the segment of the grid where I'm looking for that piece of the function. Now that I've located that, I'm going to go ahead and erase that. And I'm going to use a different color. Let's use whatever color I have as the custom green. Okay, so I'm just highlighting the part that we're looking at right now. Okay, now if I want to know what the equation of this is, the easiest way for me to find the equation of a line from a graph is usually y equals mx plus b, right? Y equals mx plus b. And in this case, we could replace the y part with mx, the f of x notation. Okay, so that's function notation is just another way of saying y really when you're dealing with functions. All right, so I know that I need to find the m, which is the slope, and the b, which will be the y-intercept of that green section of the function there. So what I want to do is um, I think I'd like to find the y-intercept first. So I'm going to go ahead and extend the graph of this function, just pretending like, I want to pretend like it's going to keep going, right? Um, so I'm going to go and connect and keep going. Okay, and so I can see it looks like the graph is crossing the y-axis at -2. So I could say f of x is equal to some slope times x plus a -2, or easier way to write that more simply just mx minus 2. Right, so I've got the y-intercept written down. Now to get the slope, I would just count from any 2 points up and over. So I'm just going to pick a couple of points. I'm going to pick this point right here and then this point right here. And notice that to get to that point from the first point, so starting at the first point, I would go to the, I would have to go down, so that would be a negative rise. So I'm going to say my slope, which is rise over run, and up would be positive rise, and down will be like negative rise, right? So I know so far I'm going to say that my rise is negative, and I only had to move 1 unit down to be on level with the other point. So I'm going to say -1 to go down. And then also when I move horizontally to the side, I'm moving to the right, which is in the positive direction of x. So that will be a positive move of 1. So my run is +1. And then just simplifying that would be -1. So now I can replace that where the m is in my function equation, and I have f of x equals -1 times x minus 2, or we really usually don't write the 1. We would just say -x minus 2. Okay, so that will be the answer in the first answer box, right? Because you see this part, the f of x is already out there, f of x equals, so I'm just filling in the right side of my function equation that I just did, okay? Now I'm going to do a similar thing for the other parts of the graph. So I'm now going to look at the next answer box, and I'm going to look at what what it says for what x would be. So it says, for the next answer box, it says if x is between -1 and +3. Okay, so I'm going to go where x is -1 and where x is +3, and then I'm just going to connect that, and I'm going to shade until I'm covering that function. Okay, so you can see that this is the piece we're interested in for that second answer box, right? The horizontal line. Now a horizontal line is really just telling you what the y value has to be. And usually if the line keeps on going, okay, so if I were to see this line continuing in each direction instead of it just being a segment, then notice that all x values would be valid, and the only thing that matters really that's, something we have to talk about is, hey, notice that y is restricted. The only value you can ever have here is going to be -3. So that's why we would say that the function equation would be, y equals 3, or -3 rather, and then f of x is equal to -3 is how we would write that in function notation. Now, because it's just segment, um, that's why you have the if part, okay? That's why it says if x were between -1 and +3, then you would have to use this piece. You would have to use this equation to find an answer. So then y would just be -3, okay? All right, good. So that's done. Yep, that's all we had to do is put -3 in that box. All right, now, guess what? We already did the 2 on the left. Now, obviously, this one's got to be the last piece we're going to look at. And it says for x is greater than 3. And notice that if I go to 3 and greater on the x-axis and shade, it covers up that function. Okay, so this is all very, it's all coming together. It makes sense. All right, so now I'm just going to focus on what that function would look like, or what that line would look like if it just continued the way we are accustomed to seeing a line being graphed. Now, the last time when I did this piece over here, I started by finding the y-intercept, which I don't know really why I wanted to do that. It actually kind of makes more sense to find the slope first. So it doesn't matter that much, but you kind of end up having to know the slope to really do a good job of extending the line graph. So if I first figure out, find 2 points that are on an intersection of the grid lines. They have to be on an intersection of the grid lines, because otherwise you can't be certain of what the values are. Like if I picked one of the points that was like somewhere like that, it's not going to be clear what the exact values of the coordinates for that point would be. So you want to make sure to pick something that actually is right on a crisscross of the grid lines. So I'm picking I'm picking this point right here and this point right here. Now I just want to see what is the slope. So again, I'm going for y equals mx plus b, but I'm going to write it with f of x because it's function notation. And really, my answer is just going to be whatever ends up on the right side once I find out what my m and my b are going to be. Okay, so all that to say, what is m and what is b? Okay, so m, again, we know is rise over run. And what we mean by rise is that starting at one point, how far do I have to move up or down to get on level with the next point, with a next point, any next point really. But I've already picked the points I want. So I'm going to go up, and now I'm on level with the second point. And so I would say I went up 1 unit, so that would be a rise of +1. And then you're going to move horizontally to get the run. So now I'm going to move to the side until I connect with that point. And so I had to move 2 units to get over there. And I was moving to the right, and that's a positive direction for x because x values get bigger to the right. So I will have a 2 there. Okay, so my slope is 1/2. Okay, so I'm going to write 1/2 there. Oh, what about my b? Well, now that I know what my slope is, it will help me to extend this graph because I can take that convenient point on the grid line intersection and I can count down and backward. So I'm just reversing the steepness, the rise over run. I'm doing it in reverse, down and one down and two backwards. And then by doing that, I have now figured out what the y-intercept would have been if this line were to have, been continuing on. So I got a -1 for my y-intercept. So now I know the answer that goes in that last box is going to be 1/2 times x minus 1. I was about to stop the recording, but I decided I wanted to add a little bit here to close this off or to finish up here to round out this lesson nicely. You might be wondering, why would you even have pieces like, or how might you use this? Well, one way that you might use this is you could have a different kind of question. Sometimes if you're given a graph of a piecewise function or even given the equations like that in pieces. So if I was asked a question like, find f of 3, for instance, okay, what I would do if I had just the picture to look at is I would realize that since that's usually f of x, then the x has been replaced with 3. So let me go to 3 on the x-axis. Now I want to figure out where should I be on the drawing? Should I be here? No, because it's an open circle, so that's not, the function is actually not existing right there. But down below, where there's a closed dot, that is a point that exists, right? So right there, the coordinates are 3 for x, comma, -3 for y. So then my answer would be -3, okay? Because remember, the f of x is another way of saying y. Or let's do another one. If, let's say I was given or asked to find f of 3, but maybe I only had the equation to work with, then I would say, okay, so if what we're saying here is that x is going to be 3, and I'm going to plug x equals 3. I'm going to replace any x in the equation with 3 and then simplify to find the y value that will be my answer. Well, now I look over here and I go, oh, but wait, which one of these equations should I be using? Well, that's when we start seeing, well, if x is equal to 3, then it would have to be the second equation because that's where the domain includes the value of 3 for x. So then my answer would be that f of 3 is just -3. And you can notice that if I go onto that middle piece of the graph, right? Okay, but before I was saying, just imagine that all I had was the equation, but since we also have the picture, I'm going to show you how this lines up and makes sense. So if I go on that piece of the function in the graph, and I go to where x is equal to 3 there, and I write down the coordinates. Oh, wait, I already did that. I'm ridiculous sometimes. Sorry, guys. All right, so now moving on. Um, what if it was, we'll just do a couple more. So what about f of -4? Well, then I would come over to where x equals -4, and I would find a point on the drawing. And again, just getting my coordinates, really what I'm needing here is the coordinate for the y value. So the answer would be f of 4, f of -4 equals 2. And I'll just do one more. We'll do another slightly tricky one. So if I said f of -1, then what would you do if you were using the, oh man, I just got rid of way too much stuff. Hold on, let me fix that really quick. negative x minus 2, I think it was, negative 3, and like that. Okay. So if all I had was the equations, then I would go and say, well, if x is equal to negative 1, that would be this part right here. So then to find my answer, I'm going to write down negative x minus 2, and then I'm going to replace the x with negative 1 and simplify. So the double negative would become a positive, then 1 minus 2 equals negative 1. Okay, and if I was looking at the graph to answer the question, I would go to where x equals negative 1 and I would find the point that exists. So notice this one down here, if I went to this piece, it would be wrong to say that y is negative 3 when x is equal to negative 1. That's incorrect because it's an open circle, so that's not existing right there. But this one exists, and that would be where you would find the correct answer. And since your y value there is negative 1, your answer would be negative 1. Yeah. All right. Good. I hope that helped you.